Unit 302, Quadratic Functions, Notes, Part 1. We begin with the discussion of the graph of the quadratic function g of x equals x squared. The quadratic function is a function, when graphed, that is a U-shaped curve. The U-shaped curve will either have a lowest value where the U opens up, or a highest value where the U opens down. What is characteristic of the quadratic function, as you already know, is that the variable is squared. So the basic quadratic function, x squared, goes through 0, 0, and then all points that are the square of the integers 1, 2, 3, 4, 5, -1, -2, -3. So some of the points that set on the curve are 1, 1, because 1 squared is 1. 2, 4, because 2 squared is 4. 3, 9, because 3 squared is 9. And then if we go the other way, -1 squared is a positive 1. -2 squared is a positive 4. -3 squared is a positive 9. Those points, as you can see, are symmetric over a line that cuts the parabola, the name given to the quadratic curve, in half. That line is called the axis of symmetry. As is the case with all graphs, some important points on the graph are x and y intercepts. Those are the places where the graph crosses the x or y axis. So this is our y-axis, this is our x-axis. All right, so let's write down what these key features are. So the vertex of the quadratic. The vertex is the highest or lowest point on the function. Okay, it's also called the turning point. It is called the turning point because it is that location on the U or the parabola where the graph turns from decreasing to increasing, where the y values are decreasing and then they turn and they're increasing. Or if the U is upside down, if the parabola is an upside down curve, then the graph turns from increasing to decreasing. So the vertex, this is the vertex of our quadratic, our basic quadratic function, 0, 0. Your axis of symmetry, this is the yellow line. This is the vertical line that divides the parabola in half. Okay, so it divides the parabola perfectly in half. The axis of symmetry is a good line to have in the visual of the curve because you can easily see points and there's symmetric point over that line. For example, when we look at the point 2, 4, we see the symmetry point -2, 4 over the axis of symmetry. We use those points to help us create an accurate graph of the quadratic. When you do your assignments in Delta Math, you will need 5 points on the curve in order for Delta Math to graph it. X and Y intercepts. So these are the points where the parabola crosses the x-axis. Okay, those are your x-intercepts. And y-axis. That's your y-intercept. Okay, in order to find the x-intercept, so to find the x-intercept, we set y, or f of x, equal to 0. So in other words, we're finding the solutions of the quadratic, which we just studied in Objective 1. Okay? To find the y-intercept, we set x equal to 0 and solve for y. All right, now every quadratic is going to have a maximum point or a minimum point. Your max or min values are the y values of the vertex. So that's kind of important because of that word value. So you're going to need to pay attention to the question whether it says, does the quadratic have a maximum or a minimum? But you could also be asked, what is the max or min value? The max or min value is the y value of the vertex. All right, so let's try an example. What are the key features of this quadratic? All right, so I'm going to go ahead and put some arrows there. The arrows should be there. So let's start with the vertex. All right, so I'm going to check out what the ordered pair is. So that is at 1, 1, 2, 3, 4. So that's the ordered pair 1, 4. And so that is the location of the vertex of this parabola. Okay. Axis of symmetry. Now, stated up above, the axis of symmetry is a vertical line. You might also see it listed as AOS, just using the capital letters. Vertical lines in algebra are named x equals the x value. So let me go ahead and draw in my axis of symmetry. I'm using yellow. Notice I'm using a dashed line. You can dash, you can make it solid. That vertical line goes through all of the x values that are 1. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, -1. And so the name of that vertical line is x equals 1. So x equals 1. That is our second key feature. Vertex, axis of symmetry. Okay, let's do the x-intercepts. The x-intercepts, as we stated above, are the points where the parabola crosses the x-axis. So I'm going to choose a different color for the x-intercepts, and they are the place where the graph crosses the x-axis. The first point is located at -1, 0. So -1, 0. And the second place is at 1, 2, 3, 0. Notice how I am writing the x-intercepts. They are ordered pairs because by definition they are the points where the graph crosses the x-axis. Remember, that's my x-axis and that's my y-axis. The y-intercept. The y-intercept is the place where the graph crosses the y-axis. So let's get a different color for that. Let's do green for the y-intercept. So I'm going to go ahead and zoom in on my graph, and I'll put a dot there at the y-intercept. And again, the location is an ordered pair. That is the point 0, comma 1, 2, 3. So 0, comma 3. All right, so we did vertex, axis of symmetry, x-intercepts, y-intercepts, and then max or min values. So as I am looking at this parabola, the U opens down, which means the vertex is a maximum. The vertex of this quadratic is a maximum. That is the highest point on the parabola. The max value is the y value of the vertex, and that is 4. So there are no other y values on the function that exceed 4, because think about it. The highest y is at 4, and so we call that the max value. And those are the key features of a quadratic function, and those are what you will look for when you graph it. When you graph it in Delta Math, you're going to need 2 other points. So if you were graphing this in Delta Math, you would need to locate 2 other points on this curve. And we would have to be given the equation to figure those out. Here it looks to me like there's a point there and a symmetric point there. Or, so now you've got your 1, 2, 3, 4, 5. You also have your y-intercept. All right, how do we graph the function when it isn't given to us? So notice in example 1, I gave you the graph of the parabola. Right? So let's talk about graphing when it is in standard form. So standard form, f of x equals ax squared plus bx plus c. F of x is your function notation. We could also write it as y equals ax squared plus bx plus c. Well, to graph it in standard form, we need to find the vertex. So that's the first thing we're going to do. Find the vertex. Okay, and we find the vertex by using the following equation. X equals the opposite of b over quantity 2a. That is the first calculation we make to determine the vertex point. Then plug that value into the function to determine the y value. After you determine the vertex, then you need to determine whether the quadratic, whether the parabola opens up or down, okay? So that would be the next thing. If a is greater than 0, it opens up. If a is less than 0, it opens down. After that, you should find your key features. So draw in your axis of symmetry. Find your x-intercepts. Find your y-intercepts. Find another point and its symmetric point over the axis of symmetry. So let's find example 2. Let's graph. Okay? So the first thing you're going to do is you're going to find the vertex. So we're going to use the calculation x equals opposite of b over 2a. So that's going to mean that I'm going to go to the quadratic equation where I'll go ahead and list a equals 1, b equals negative 2, and c equals negative 3. I'm going to go ahead and substitute in opposite of b, so that's going to be the opposite of negative 2 over 2 times a positive 1. In the numerator, I'm going to get a positive 2. In the denominator, I'm going to get a positive 2. Therefore, I know that part of my vertex is 1. Then it says plug that value into the function to determine the y value. So now we're going to do f of 1, which means I'm going to take 1 and plug it in. So that's going to be 1 squared minus 2 times 1 minus 3. So that's going to be 1, subtract 2, which is a negative 1, subtract 3, which is a negative 4. And I also suggest that you use your calculator for these calculations. So 1 comma negative 4 is the vertex of this parabola, which I'm going to go ahead and graph. So over 1, down 1, 2, 3, 4. There's my vertex. Okay, the next thing that it said to do was if a is greater than 0, it opens up. If a is less than 0, it opens down. So I'm looking at a, it's a 1, so we know that it opens up. Why is that useful? Because now when you determine other points, you know that all the other points have to be above that vertex because the rest of the U is opening up. Okay, let's draw in our axis of symmetry. So our axis of symmetry is going to be this vertical line going through, it's still green, so I'll just leave it at green. The vertical line going through the vertex. So my AOS, you'll see me abbreviate that, is the vertical line. Vertical lines are named X equals 1. X equals the X value that the line is passing through. Okay, so key features. We have found the vertex. We have found the axis of symmetry. Now we need to find the X and Y intercepts. Okay, well, let's find the Y-intercept. To find the y-intercept, it says right up here, to find the y-intercept, set x equal to 0. So that means I'm going to go to my equation, and I'm going to plug in 0 for x. So essentially that means I am finding f of 0. So that's 0 squared minus 2 times 0 minus 3. And again, utilize your calculator, and that's going to give you negative 3. So that means this is the point 0, comma, negative 3. That is my y-intercept. So I'm going to go to that point, 0, negative 3, and plot it. Now I have just plotted my y-intercept. Now if you use the symmetry of the axis, then you know that another point on that curve is 2, negative 3. There's your symmetry over that line. All right, so now I know 2 points, and I know the vertex. I need 2 more points to get a complete graph of my parabola. So I'm going to go ahead and find my x-intercepts. Okay, well, to find the x-intercepts up above, what does it say? Set y equals f of x equal to 0. So 0 equals x squared minus 2x minus 3. This should look very familiar to you because we just did a whole objective on solving quadratics. What are our ways to solve? Well, we can solve by factoring, we can solve by square roots, we can solve by quad formula. Now at this point, this problem has already gotten pretty long, right? So let's hope this factors. So we're going to try to factor this. So we're looking for 2 numbers that multiply to negative 3 and add to negative 2. So that's going to be x minus 3 and x plus 1. So that multiplies to negative 3 and adds to 2. So we'll set those equal to 0. And we get 3 and negative 1. So my x-intercepts are at 3, 0 and -1, 0. So let's see if that looks right on our graph. So 1, 2, 3 and -1. Oh, wait, I went way too far over. Hold on. 3, 1, 2, 3 and -1. All right, does that work? Are those 2 points symmetrical over the axis of symmetry? Yes, they are both 2 units away. And so now I have 5 points, which allows me to graph my parabola. Okay, and then the last key feature, what is the max or min value? It is a min value equal to -4. And those are the key features. Now you're going to try an example on your own. So you may need to look back up in your notes. And I'm going to pause in Edpuzzle and ask you some questions. Okay? So we'll begin by what is the vertex? So I would like you to use the steps in the example to determine the vertex. So I'm going to pause. You can put it in the box and then restart the video. Okay, so let's see if you got it right. So x equals the opposite of b over 2a. And so that's going to be the opposite of -6 over 2 times 1. So that's 6 over 2, which is 3. Then you're going to plug that 3 back in, which is essentially doing f of 3. So that's 3 squared minus 6 times 3 plus 5. And again, utilize your calculator. So that's 9 minus 18, which is -9, plus 5, which is a -4. So our vertex is 3, -4. So hopefully you got it right. So we're going to go to the graph, and we're going to graph 1, 2, 3, and then down 1, 2, 3, 4. Make sure you get the vertex location correct. All right, what is the axis of symmetry? So again, I'm going to pause. You should determine what it is, and you should also plot it. Okay, the axis of symmetry is the vertical line through the vertex. And that is the line x equals 3. So again, I'll label it over here. X equals 3. Is the vertex a max or min? So again, you're going to look at the value of a. That's going to tell you whether the graph opens up or down. And that's going to tell you whether that vertex is a low point or a high point on the parabola. So go ahead and put that answer in Edpuzzle. Okay, that is a min because a is positive, and so my parabola is opening up. What is the y-intercept? All right, so to determine the y-intercept, we're plugging in 0 for x. So f of 0 equals 0 squared minus 6 times 0 plus 5. And so that gives me a value of 5. So 0, 5 is my y-intercept. So 0, 1, 2, 3, 4, 5. And then again, let's think about symmetry. So that y-intercept is 1, 2, 3 units from the axis. 1, 2, 3 units gives me another point. Okay, it says graph using the information from A to D. Hint, find the x-intercepts too. All right, well, let's go ahead and find the x-intercepts. So to find the x-intercepts, we're going to set f of x, or y, equal to 0. And I'm going to go ahead and pause the video. And I'm going to let you factor to solve for the x-intercepts. Go ahead and put them in the box and then restart the video. Okay, so this is going to be x minus 1, x minus 5 equals 0. Therefore, x equals 1 and x equals 5, which means my intercepts are ordered pairs, 1, 0, and 5, 0. So let me just point out the difference here. It's very subtle. These are the solutions, okay? And these are the x-intercepts. Please note the difference in the way they are displayed. Okay, so 1, 0, 0.10, and 5, 0. And so now we have 5 points, which allows us to graph the parabola. And that is graphing a quadratic in standard form. The other type of graphing that we're going to learn is graphing in vertex form. Okay, vertex form is an entirely new form to you. F of x equals a, parentheses x minus h, parentheses squared, plus k. This is a completely new form. The value of a is similar to the a in standard form. The letters h and k represent the vertex of the quadratic. In the form x minus h, you pull out the value as a positive h and k as a positive k. If it were written x plus the number, then you take the opposite of it for your h value. So all you need to do in vertex form, it's actually easier than standard form because in the form you're given the vertex. There's no calculation here. So you find the vertex, then you do axis of symmetry, and that's x equals h, that's your h value. Then you do y-intercept and x-intercepts, and you graph. The x-intercepts are a little more complicated in this form. So you can also, I'll just put a little star there, find points on the graph by plugging in x values near the vertex. That's another way to find additional points on your parabola. Okay, so here we have our quadratic in vertex form. So vertex form. This is your h. This is your k. It is written x minus 2. So that means we just pull that out as your h value. This is minus 4. So together with that minus 4, that is your k value. So the vertex of this is 2, negative 4. 2, negative 4. We're going to go ahead and plot it. So 1, 2, 1, 2, 3, 4. What were other things that we found, key features? Axis of symmetry. So let's go ahead and plot our axis of symmetry. I'm going to use purple now. Vertical line through the vertex. Vertical line through the vertex. So my AOS, my axis of symmetry, is the line x equals 2. So I'll go ahead and label that. The next thing we found was x or y-intercept. So let's find the y-intercept. So that means I'm going to plug in 0 for x, right? So that means f of 0 equals 0 minus 2 squared minus 4. Order of operations. Do parentheses. 0 minus 2, negative 2, squared, positive 4, subtract 4, 0. So that means 0 comma 0 is a y-intercept, and it's a bonus because it's also an x-intercept, because that's a place where it's crossing the x and y-axis at the same time. So if that is an x-intercept, we can find the other one by using our line of symmetry. So x-intercept 0, 0, and let's figure that out. 1, 2 units from the line of symmetry, 1, 2 units from the line of symmetry. So that's 4, 0. Now we only have 3 points here. We need 5 to be able to get an accurate graph. So let's go back up here to what I wrote in the box. Find points on the graph by plugging in x values near the vertex. So the vertex is the point 2 comma negative 4. So an x value near that is 1. So I'm going to plug in x equals 1. So that means I'm going to calculate f of 1. So that's going to be 1 subtract 2 squared minus 4. So again, plug in x values that are near the vertex. The vertex was sitting here at 2, negative 4. So I chose to plug in x equals 1. Order of operations. 1 minus 2 is negative 1. Squared is positive 1. Minus 4 is negative 3. And again, please feel free to use your calculator for that. So that is the point 1 comma negative 3. All right. So 1, negative 3 right there. Do your symmetry point to the opposite side of your line of symmetry. And now let's draw our curve. And there it is. And that is the end of notes, part 1. Okay, so let's move on to our notes, part 2. And we're going to talk more about graphing, about finding our x-intercepts, and finding x-intercepts that maybe aren't integers. So again, let's review what our features are on our quadratic function. We have our vertex, we have our axis of symmetry, x and y intercepts, and we also like to determine the max and min value of our function. So let's start with example 1. What are the x-intercepts of this quadratic function? So graphically, if we were to determine that, that means we would begin by finding the vertex of the quadratic. So the vertex is going to be x equals the opposite of b, so that's the opposite of negative 6 over 2 times 1, and that gives me a 3, so x equals 3, and then of course we plug that 3 back in, so we do f of 3, which is going to be 3 squared minus 6 times 3 plus 8. So that's going to be 9 minus 18, which is negative 9, plus 8, which is a negative 1. And so my vertex is 3 comma negative 1. Oops. So 1, 2, 3, negative 1. I know that I'm going to have my axis of symmetry here. and we've got to figure out where it goes through the x-axis. Now, it kind of makes sense to me. First of all, we know the quadratic opens up, that it's going to go through kind of near there, right? Near 3, -1. So how do we figure that out? Well, we could just start plugging in some values. So let's plug in 1, 2 for x. So let's figure out what f of 2 is, okay? So that's going to be 2 squared minus 6 times 2 plus 8. So it's going to be 4 minus 12, which is a -8, plus 8 equals 0. So we figured out that when we plugged in 2, we landed on 0, which is in fact an x-intercept. And if we use the axis of symmetry as our mirror, then we can mirror over to the other x-intercept, which is at 4, 0. So my x-intercepts are 2, 0 and 4, 0. And so y-intercept, if I plug in 0, let's just finish it off with our key features. If I plug in 0 for x, eventually you're going to start realizing in standard form, the y-intercept is always c. So it's 0, 8. And again, your mirror point, and now you've got a nice little graph. Now notice the problem just asked for the x-intercepts, right? Just asked for the x-intercepts. Well, we just kind of guessed here graphically by plugging in 2. Algebraically, we do what I spoke about in the parts 1, which is we set the function equal to 0 and solve by factoring, square rooting, or quad formula. Obviously, factoring is usually the most efficient and easiest way to do that. So if we factor what multiplies to 8 and adds to -6, x minus 4, x minus 2. They multiply to positive 8, add to -6. Set those equal to 0, and you will see we got x equals 4 and x equals 2, which translates into our ordered pair 4, 0 and 2, 0. So we can find them graphically, we can find them algebraically. Let's look at example 2, where the quadratic is not in standard form, it's in vertex form. So, and notice I highlighted this, and it's bold, capital letters, and it says exact. And notice I don't have a graph there. So we're not going to graph to find them. To find the x-intercepts, we are going to set f of x equal to 0. And we're going to solve. This is in vertex form. We're not going to solve using the quadratic formula. We're not going to solve by factoring. So the only other option left is to solve by square rooting. So this should look similar to something you did on the quiz. So we're going to add 3 to both sides, because solve by square rooting means we need to get the squared piece of the equation by itself. We need to isolate it. So that's 3 equals x minus 5 squared. Now we are going to square root both sides. So plus or minus, we remember that from square rooting, 3 equals the square root of x minus 5 squared. Plus or minus the square root of 3. The square root is the inverse operation of squaring, so we're left with x minus 5, and I can now drop the parentheses. And therefore, to solve for x, we're going to isolate x, we're going to add 5 to both sides. And so how do I write that? Because 5 cannot be combined with plus or minus root 3. And so we write it as 5 plus or minus root 3 equals x. to write that as an ordered pair, you have some options. You can throw it into an ordered pair like this, 5 plus or minus root 3, comma 0. Or if you wanted to, you could write them separately. 5 plus root 3, comma 0. 5 minus root 3, comma 0. We call those the exact x-intercepts because those are the exact locations in the coordinate plane, not a decimal approximation. If you had come back over here and turned the square root of 3 into a decimal, and then went over here and added it to 5, you're giving an approximation to where it is in the coordinate plane, not the exact location. All right, so x-intercepts. Sometimes they are nice integers, like in the first example. Sometimes they involve irrational numbers or square roots. We're now going to talk about two more key features of a quadratic function, and that is the domain and range of the function. What is the definition of domain? The definition of domain is all the possible values that can be used as an input into the function. So all of the x values that you could plug in to the quadratic. And we write it using interval notation. Now you'll notice here in this arrow, it says since the graph continues down toward the left and down towards the right, the domain contains all real numbers from negative infinity to positive infinity. Because we can keep plugging in x values and you will keep getting y values. So we write that, let me write the word domain using interval notation, parentheses, negative infinity, comma, positive infinity. That represents the domain of that function. We can plug in all real numbers. It's written here. All real numbers can be used as inputs to that quadratic function. The range. The range is the set of outputs. So domain, those are your inputs to the function. The range is your outputs. What values of y come out? Domain is also your x. So I'll put that above it. X values. And your range are your y values. Now, what's unique about a parabola and a quadratic is, as we talked about in part 1 of the notes, there's either going to be a highest point to the parabola or a lowest point to the parabola, because that's what makes it have the shape of a U. And so for your y values, there is an ending point. So either y is going to reach the highest point or y is going to reach the lowest point. And that comes into play when we write the range. So let's read what it says in the arrow. Since the maximum y value of the function is 5, so that's right here, because that's our vertex, right? So that's the maximum y value is 5, okay? And the graph continues to extend downward. The range contains all real numbers less than or equal to 5. So my range is all y's less than or equal to 5. Now, how do we write that using interval notation? This is new for you. Now, think about down here. Those arrows are pointing towards negative infinity, okay? Your range is always lowest y, comma, highest y. That's true for the domain too, but the domain is always negative infinity to positive infinity. But your range, when you express the range using interval notation, it is always the lowest y value, comma, highest y value, always, whether the parabola opens down or opens up, okay? The lowest y value here, look at the arrow, look at the red arrow. It's pointing down towards negative infinity. So negative infinity, comma, the highest y value is the max value. That's 5. And if you recall from last semester, bracket means include the value. Okay, that was a lot to take in. So let's do an example and I'll reinforce that. Okay, what is the domain and range of the function in vertex form? Okay, so this is in vertex form. So as we remember, this is going to be x minus h squared plus k. So to interpret that, that means h should be written x minus a negative 3 squared, right? And then minus 4 would mean our vertex is negative 3, negative 4. So sometimes you have to rethink it in your head to pull out the h value. So negative 3, negative 4. So negative 1, negative 2, negative 3, 1, 2, 3, 4. There's my vertex. The a value. What is the a value? Well, it's sitting over here. It's a 1. It's positive. A is greater than 0. The parabola opens up. So a is greater than 0. The parabola opens up. Now, I don't need a full graph of this to be able to write my domain and range. So I'm just going to do a quick sketch so that I know my parabola opens up. And then I'm going to think about the domain and the range. Okay? The domain, it's always negative infinity to positive infinity. The range, well, let's look right up here. Lowest y to highest y. Now, those arrows that I put on my graph are important because those arrows are shooting for the sky. They are shooting upwards, and upwards means they are going towards positive infinity. That's the direction they are heading. My lowest y, well, let's write what the ordered pair is for the vertex, negative 3, negative 4. So my lowest y is right there. That is the lowest y value. Okay? So that means my range is negative 4, lowest y, comma, highest y. You can write positive infinity. You can just write infinity. Whew. All righty. Let's do our next example. All right. And then you can see this is the last page of day or part 2 notes. Okay. So what is the vertex? So I'm going to pause and see if you can come up with the vertex. It is in standard form. So I'm reminding you, you're using x equals opposite of b over 2a to find the vertex. So once you determine it, go ahead and put it in the box in Edpuzzle. Okay. So let's see what you got. So I got a 2 for my x value. And then I'm going to go ahead and do f of 2. So I'm plugging that 2 value back in. It's going to be 2 times 2 squared minus 8 times 2 plus 8. So that's 4 times 2 is 8, minus 16 is a negative 8, plus 8 is 0. So did you get a vertex of 2, 0? I hope so. All right, axis of symmetry. I'm going to go ahead and pause and let you write that equation in the Edpuzzle box. Okay, did you get the line x equals 2? And I'm reminding you, the axis of symmetry is not the number 2. It is the equation x equals 2. Is the vertex a max or min? All right, so go ahead and look at your a value. Think about if the parabola opens up or down and write it in the box. Is it a maximum or a minimum? Okay, it opens up, so the vertex is a minimum. Part D, what is f of 2? Okay, I'm going to give you a little hint by highlighting something over here, and then go ahead and put in the box what f of 2 is. And hopefully you put in 0, because we already calculated f of 2. What is the domain? Well, we always know the domain of the quadratic is negative infinity to positive infinity. What is the range? Well, I'm going to pause on the range for a minute until I graph it, until I can actually look at the graph. What is the y-intercept? Well, the y-intercept occurs when x is 0. So I want you to go ahead and calculate f of 0. Go ahead and put that in the box in Edpuzzle. And after you do a few of these, you will realize that the y-intercept is always 0, c. So whatever the c value is. So it's 0, 8. X-intercepts. Well, to figure out the x-intercepts, I have to figure out 0 equals 2x squared minus 8x plus 8. Now I see a common factor of 2. So I'm going to go ahead and divide everything by 2. And that's going to be 0 equals x squared minus 4x plus 4. And when I factor that, that's going to be x minus 2, x minus 2, which means when I set it equal to 0, I'm going to get one x-intercept. And that's at the point 2, 0, which I already knew from part A. Because the vertex, now we have an example of a quadratic where the vertex is also the x-intercept at the same time, okay? Our axis of symmetry, x equals 2. Let's go ahead and get that line graphed. That's the line x equals 2. Y-intercept, we said, was 0, 8. Okay, so that's way up there. 1, 2, 1, 2. Okay. We only have 3 points. We need 2 more points to have an accurate curve. And so this is where I said in the other notes, pick an x value near the vertex. So I'm going to pick x equals 1. In other words, I'm going to find f of 1, right? So I'm going to go up to my equation. That's going to be 2 times 1 squared minus 8 times 1 plus 8. Use of your calculator, super helpful. So that's going to be 2 minus 8 is a negative 6, plus 8 is 2. All right, so that means the point 1, 2 is on the graph. And that makes sense because look where it falls. So there's 1, 2, symmetry point, 3, 2. Now I can get my curve, my u, my parabola. Okay, so the only thing we didn't answer yet was what is the range? So reminding you, the range, lowest high to highest y. Okay, my lowest y value is 0 because that's the point 2 comma 0. My highest y is way reaching towards infinity. Okay, last example for this. Given the quadratic function, determine the following. Now notice I'm not asking you to graph it, okay? So just using the equation, can you figure out this information? So the vertex, okay, again, this is in vertex form, x minus h, so we pull the 1 out as h, minus 4, negative 4. So 1, negative 4. Axis of symmetry, x equals 1. So it is the vertical line through the vertex. My zeros, my x-intercepts, well, that means I have to write the equation equal to 0. So 0 equals x minus 1 squared minus 4. How do I solve that? Well, we did that in objective 1. Solve by square rooting. Okay, so I'm going to add 4 to both sides. And that's going to give me 4 equals x minus 1 squared. I'm going to square root both sides. So plus or minus the square root of 4 equals x minus 1. That's plus or minus 2 equals x minus 1. And so x equals, I'm going to add that 1 to the other side, 1 plus or minus 2. Well, what is 1 plus or minus 2? Well, 1 plus 2 is 3. So 3 comma 0. 1 minus 2 is negative 1. Now notice it said zeros, x-intercepts. If it's asking you for the zeros, you're just going to write it as 3 or negative 1. So just reminding you that it's a slightly different answer. Is the vertex a max or min? So let's look at the a value of our function. A is 1. That means it's positive. That means the u is opening up, which means the vertex is the lowest point. So the vertex is a minimum. All right, U302 notes part 3. Now on this particular set of notes, we are going to utilize the graphing part of Desmos, or I'm going to have you pause the video and download a free app called Graph and Calc 83. So you're welcome to use either one to help you with this section of the notes. We are going to use Desmos to help us locate zeros, the vertex, and the values of the function at certain inputs or outputs. There is a video that I'm going to have you click the link to here, this YouTube video. I'm not going to embed it in the notes because otherwise there's feedback. And I want you to click on this, pause your notes, watch the introduction to using Desmos. Then go ahead and open Desmos on your graphing calculator or on your iPad. Okay? So I'm going to go ahead and open up Desmos. I'm not quite sure I have it. Desmos, Desmos. Okay, graphing calculator. And it should look like this. All right. All right, I'm going to go back to our notes. And we're going to start with the first example. Input the equation into Desmos. You can use y in place of f of x. all right? So I'm going to go back, and the equation is x squared minus x minus 6, all right? So I'm going to go back to Desmos, and I'm going to type it in y. So where's the y value, right? So it's right there, y equals x, and then the squared, right here, the a squared, minus x minus 6. You can push the menu down by clicking that. And now you see that Desmos has graphed the quadratic for you. Quite simple, right? And not only will it graph it for you, but it will find the key points that we've talked about in parts 1 and 2 of our notes. All you have to do is literally touch the place where you believe the vertex is, so the lowest point or the highest point, and Desmos will display the ordered pair. If you click that gray point next to it, that is, of course, the y-intercept because it is sitting on the y-axis. If we go over here to this gray point, we now know the x-intercept. We go over here to that gray point, we know the other x-intercept. All right, so let's go back to our notes. What are the solutions, zeros, roots, x-intercepts for this quadratic? All right, well, depending on what you're being asked, the zeros are x equals -2, x equals 3. Those are my zeros. Notice I'm asking for zeros, but if I asked you for the x-intercepts, then you're giving them as the ordered pairs, which Desmos, when you clicked on it, it clicked on those ordered pairs. Does this quadratic have a max or a min? Well, it's got a min because it's the lowest point on the curve. What is that max or min value? So I would go ahead and look. The max or min value is the y value of the vertex. So that's -6.25, right? What is f of 4? All right, well, f of 4. Let's see, I'm going to look at my x-axis, all right? And I see that x equals 4 is right there. I can follow that up to where it touches the curve. And that should be the value of f of 4. Now, it's hard for me to do that in our notes, so I'm going to go back to Desmos. And I'm going to click on some points here. So 1, 2, 3, 4. I think that's right around, let me zoom out a little. Maybe right there. So I'm trying to hold it down and see where 4 is. Oosh, it's kind of hard to get it. It looks like it's at, looks like it's going to be 6. So what about if we graphed x equals 4? So in other words, where is x equal to 4? Ah, right at that point, right there. So that then told me that f of 4 is 6. So back to my notes, f of 4 is 6. You also could just plug the 4 into the equation, right? Pretty easy. Okay, use Desmos to find the zeros and the vertex of these quadratics, all right? So you're going to go ahead and type in x squared minus x minus 6, all right? Also, I think I downloaded that graph in Calc. Let me look for it. Let's see if I could demo one here. Oh, that's Calc 84. Oh, nope, wrong one. Okay, I don't have, let's see, graph. Let's try to type it in. Y equals, no, I'm not going to do this. I don't know this one. So I'm going to go back to Desmos. Way easier. So you press the X to get rid of any graphs you already have. Let me just remind myself again what my notes were. X squared minus x minus 6. So x squared minus x minus 6. Okay, bring the menu down, maybe reposition your graph. All right, And let's see if we can find the vertex and the x-intercepts. So one x-intercept there, another x-intercept there. And notice that when I touched the curve, those gray points appeared. All right? So you might need to have another piece of paper to write that down so that you can answer those questions. So negative 2, 0, 3, 0. Okay, so my zeros, x equals negative 2, x equals 3. Notice how I'm writing them. I'm not writing them as ordered pairs because it said use Desmos to find the zeros. Those are like finding the solutions. Okay. Vertex. Wait, that was the same one that we just did, right? X squared minus, I don't know why I retyped that in. So the vertex, 0.5, negative 6.25. It was the same equation and I didn't even realize it. Good Lord. The vertex is a min and that min value is negative 6.25. I don't know why I just had to do that same one again. All right, let's do the second one. Negative x squared minus x plus 12. Okay, so negative, oh, and notice I didn't even put y equals, and it's still graphed. Negative x squared minus x minus 12. Oh gosh, I hope that's right. I have to go back and look. Negative x squared minus x, oh, plus 12. Okay, let's try that again. Plus 12. Got it. Okay. And again, reposition so you can see most of the curve. All right. And then if you touch the curve, notice how I just tapped the curve? The gray points appear. X-intercept, x-intercept, y-intercept, vertex, right? If you want your curve to be a different color, you can come over here to the little squiggle next to the equation, right? And hold it down, maybe? I can't remember how you change the color. I thought you just held it down. Oh, yeah, you do. You hold it down, and then you could change it to like a blue, purple, whatever you want. Okay. Oh, you got to tap it again because I lost all my critical points. All right. So x equals negative 4, x equals 3. Okay. What is the vertex? The vertex is negative 0.5, 12.25. So negative 0.5, comma, 12.25. The vertex is a max. Take a look at that graph. That is the highest point. So the vertex is a maximum. Okay, so it's a max. And that maximum value is the y value. So you can see by using Desmos, you save so much time on the calculations of finding the vertex, the x-intercepts, the y-intercepts. So why am I showing you this? Because we're going to use Desmos to solve quadratic applications. The most common, you might end up using them when you take physics, or maybe you're already using them in physics, are modeling. Objects, physicists love to do experiments, and they love to drop things and throw things. And there are equations that model the time versus the height of objects when you drop them or throw them. And when I say model time versus height, I mean in an experiment, you might take some data points, like what's the height of an object at the start? And then 1 second later, what's the height of an object? 2 seconds later, 3 seconds later, 4 seconds later. And when you plot those points, they're going to show up as a quadratic function when you are modeling a falling object. And these are the two equations. You do not have to have them memorized, right? But you do have to be able to recognize the different pieces of information in the equation. So let's go through what everything is, all right? We're going to start with t. T always represents time. So t represents time. So what's it going to look like in an equation, in a word problem? Well, some key phrases might be like how long or when. Those would be questions where they're asking you for the time, how long or when. H of t is the height. So h of t is the height of the object at time t. So h of t is the height, because the height changes. Because when you drop something, it's going to be at its highest point, maybe, and then it just falls to the ground, and it's going to be at different heights as it falls. Or maybe you launch something, and it goes up into the air, and then it falls back down. It's going to be at different heights at different times. H sub 0 is known as the initial height. That is called a subscript, and it is read H sub 0. Sometimes physics teachers or physicists call it H naught, meaning what is the height, the initial height, the beginning height, starting height. Okay, V sub 0. V sub 0 is the initial velocity. What is velocity? You could think of velocity as like that extra push you give something when you throw it. So in other words, you could just have something in your hand, put your hand out the window, let go, and the object drops. You are not giving it any extra oomph or push. Or you could open your window, stick your hand out the window, and throw something. You're giving that object velocity. So initial velocity. Your vertex is either the highest point or the lowest point. For these models, it is the highest point of the function. Okay, so it is the height at time t. Now, that doesn't necessarily mean that is the initial point, because your object could be launched and therefore it's not at its highest point when the experiment begins. So let's use Desmos and let's answer some questions. If you draw, okay, and by the way, here's your equations. Whoops, I got ahead of myself. Here are the equations you're going to focus on. Why are there two sets of different equations? One of them has velocity and one of them doesn't. So I want you to pay attention to that. Object is dropped, object is launched or thrown. That's how you know which equation to use. Look for those keywords in your problem. If you drop, there's our keyword right there. An object off the roof. Oh, one more thing. Why two different sets of equations? Notice what I have written here. One of them is in feet, one of them is in meters. One of them is in feet, one of them is in meters. Okay, let's go back. If you drop an object off the roof of an apartment building that is 240 feet tall, okay, that's important right there. Feet means we're using the feet equation. How long will it take for the object to hit the ground? How long? Ooh, let's go back. How long? That was a time question. Will it take for the object to hit the ground? The ground. The ground has a height equal to 0. These are important things when considering how to fill out the formula and answer the question. All right, so we know we're using the dropped one and we're using the feet one. So h of t equals negative 16 t squared Let me go back up, plus h sub 0. All right. It says you drop it, so somehow you are at the top of your apartment building. All right. Be careful up there. So h sub 0 is right here. That's my initial height. So that means h of t equals negative 16t squared plus 240. What are we doing? We are finding how long until the object hits the ground. The ground is 0. So that means this is going to be equal to 0. So 0 equals negative 16t squared plus 240. Now you got two options here. You can either just straight up solve that, solve by square rooting, or you can type it in to Desmos and find t when h is 0. Right? So negative 16t squared plus 240. So I'm going to go back to my Desmos, okay? And instead of t, I'm going to use x, okay? So negative 16x squared plus 240. Now go ahead and manipulate your graph so that you can actually see a parabola. And sometimes it's like kind of a little hard to see it, right? Depending on your scale. Let's talk about a couple things. First of all, the only quadrant that matters is the first quadrant because that's where time is positive. And your parabola starts at 240. We already know that. We already know because that was the initial height, right? Right there at 0, 240. And so the object is falling. How long before the object gets to the ground? Now watch what I'm doing. Why am I going like this? Because I want to figure out at what time the height, which was starting up at 240, gets all the way down to 0. Okay?